Beautiful.
Welcome, everyone. This is Tech Talk episode number 10. And as a reminder, if you've missed any of the previous ones or would like to watch them over, you can visit the Baseline Web Training account on YouTube. And Dan's put all the previous Tech Talk Tuesdays up there. And we'll start with the introductions. I'm Andy Humphrey, Regional Sales Manager to Northeast. We have Dan Conger, Training Manager, and Chris Wright, VP of Sales. And our topic for today is going to be working with water windows and difficult water windows. And Dan's going to take us in. I'll just speak for a second from my own experience. Water windows become a frequently asked question in terms of how to solve with them and how to configure and set up the controller to work with them. And so just as a regional sales manager with contractors and users reaching out to me, this is definitely one of the most frequently asked questions, how to set this up. So glad we're covering it today. And Dan, why don't you take us away?
Cool. Okay. So water windows are really what describes the limits on how or when you can water your site. And we're not talking about these programmable water. We're not talking about the programmable water windows in the controller. We're getting more sophisticated than that. So if we kind of look at the limits on watering your site, there's really two limiting factors, right? I think everything condenses down to this. So the first one is your water source capacity. So we're talking about the GPM or the flow rate from your water meter or your pump, right? Those are the two. That's limiting on your water source. And then ultimately the time that you have to water. That's either the hours in the day or some other limits that are placed on you. So I'm going to share my screen and let's show you. Here I've got a site. It's a park site. And this site has a 2-inch main line. So I looked up what a 2-inch main line could carry, and 2-inch main can carry 50 gallons a minute. And now I think it's worth mentioning where a great place to get this information is every manufacturer that manufactures heads or valves or plastic parts has a chart in the back, and it's a friction loss chart, and it will show you the capacity for every different size of pipe. This site also has 40 zones, and each of the zones runs for about 30 minutes. So, and then the zones average about 25 gallons a minute. So that's kind of some of the statistics on the site. So we're going to applying a little bit of math. If we take those 40 zones times 30 minutes, we get 20 hours of watering. And then fun fact is that's about 30,000 gallons for a cycle. So what's kind of worked out really well on this one is they've got 20 hours to water. There's 24 hours in a calendar day. So they have enough time to water the entire site in 20 hours. They even have a 4-hour break. That doesn't sound very realistic though, does it? So
yeah, and I think Dan, you're using 30 minutes as an average, knowing that some zones may be 15 or 10, and some zones may be 45 or 60, right?
Absolutely right. But it's my starting point to get to this 20 hours. Absolutely, yeah. Now, but to have a full 20 hours in which to water a site, that meets 24 hours, but that's about all it meets. It doesn't fit with what really goes on in the world, right? So this park has some softball, it has Saturday sports, they have Thursday concerts, you've got conservation restrictions. These are all things that we have on our sites that cut down that 24 hours to less time. Because you're never going to get more than 24 hours to water. That's just the way, that's just time. It's always going to be less than that. So if we're going to do a little bit of math on this one, and I'm going to take my 12 hours now of my watering time and turn it into minutes. So it's 720 minutes total watering time that's allowed on the site. And then I'm going to take that 30,000 gallons and divide it by the 720. That means I need to average 42 gallons a minute to complete the watering within 12 hours.
Mm-hmm. So, and you would, if you were designing this system from scratch, i.e. it's new construction, most irrigation engineers, designers, consultants would go through these hydraulic equations
Right.
at step one to try to figure out if that should be a 2-inch pipe or 1.5 inches or a 3 or a 4-inch. But it's not always that we have the luxury of either the right size pipe or a properly designed irrigation system.
Well, and I think it's, yeah. And why is it a 2-inch? Why didn't they put in a 3-inch? Why didn't they put in a 4-inch? That would have made this so much easier. Well, right. Isn't it about money?
Mm-hmm.
It's usually the case why someone value engineered it initially and started off with a 3 or a 4-inch. It's like, oh, we could save some money and turn it down to a 2-inch, not knowing that it's going to haunt someone and be an issue for them later on down the line. So we need to average 42 gallons a minute. We could be a little bit less, but when we're less than that, we're going to have other times when we're running more than 42 gallons a minute in order to complete our watering in a full 12 hours. So here's the way we're going to do that. The simplest way to do that is to run more than one zone at a time. So one of the settings is called concurrent zones. And all I did in here was in the program, I went in and changed the program concurrent zones to 4. So I said, this program can run 4 zones at one time. Now, I think it's a great question. How do I know that I can run 4 zones at a time? Well, since we have 99 different programs we can work with, what we can do is put all the drip zones into a program and say, this drip zone program can run 4 at a time, just as long as those 4 combined don't exceed the 50 gallons a minute. So that's a good start on running, condensing our water window. So, but there's a more sophisticated way to do that. So, but this is like the first place that it's great to start with, right? Is let's get our low flow zones into a program and then change the concurrency on it. Now, what might happen is the big rotor zones, the concurrency might only be 1 at a time. We might not be able to run 2, 3, or 4 at a time. But for some of these smaller zones, we could take advantage of our larger main line rather than just running them 1 at a time.
Yeah, and I think that most contractors have a gut feeling about the size of the zone. Let's just say small, medium, and large. And so without jumping too far ahead, at the most basic level, like you just said, you can take those small zones, put them in a program, and perhaps, using that 50 gallon a minute criteria, maybe each of these zones is, 10 gallons a minute. And so 4 times 10 would be 40 gallons a minute. It fits inside there. So even if you happen to be a little bit high or a little bit low, it's a great place to start.
Right. Exactly. Right. I think this is a good starting point. But then the more sophisticated way to do it is what we call manage by flow. So manage by flow is taking that 50 GPM design flow, and then we're going to run multiple zones at once up to that 50 GPM, but not exceeding it. So you see in there, right under flow management, we inserted design flow. That's the exact 50 gallons a minute. That's the capacity of my 2-inch main line. And then I've clicked the manage by flow box. So what would happen is I could run 2 25 GPM zones, or the controller could find 2 25 GPM zones, or it could find a 40 and a 10 because that meets 50. It might even find 3 zones, but never exceeding 50 gallons a minute. So it's going to be maximizing that mainline capacity for as much as possible given the zones that we have. Now, if I only have 45 GPM zones, well, there's no one else to mix in there. But if I have smaller zones, we can puzzle piece those, if you will, together. There's a few steps that we need to do to make manage by flow work. We have to give the controller some data. So one of the first things we need to do is we need to learn flow. So the controller needs to know what the expected flow for each zone is going to be. So we talked about learn by flow in an earlier webinar. This is just exactly that. So, now, Andy, does everybody that you run across, do they all have flow sensors to learn flow?
Yeah, that's interesting because I do think we're seeing more and more flow sensors being installed, especially as more controllers just in the world are capable of reading them. It's becoming more top of mind to use them. but not always. So let's just assume that 50% or more of controllers out there do not have flow sensors. I think where you're going with this is you can actually enter that flow information. So when somebody calls me and they want to know how to run multiple zones at a time, this is generally how I instruct them to configure the controller without a flow sensor, is just to simply enter the flows of each zone manually to as close as they can. Take 2 gallons a minute per sprinkler. If they think that's the right nozzle, multiply it by 10 sprinklers, enter that value.
Yeah, when I first heard that, I thought that's pretty genius, right? That you don't have the hardware on the ground that you need, but you've got the capacity of the controller. Let's put that information in manually.
Yeah, let's let the controller do the hard work.
Yeah. Now, I think it's ideal. I think it's time saving, and it's probably quicker to learn flow. But if you don't have that option, you can manually enter it. The next step is to set our design flow. This is where we're going to tell the controller the capacity of our pump over our main line. So it's really, I'm coming into this design flow. Here I've set it at 50 gallons a minute, and then I'm going to save it. That's relatively simple. It's simple to enter it, but it's really important that we get that right number. Now, if I guessed at my design flow and I put in 200 gallons a minute, it's going to try and run 200 GPM worth of zones, and my system isn't going to operate very well, right? And if I put the number too low, we'll be underutilizing the main line. So this is definitely worth a little bit of research, a little bit of looking up to make sure we get the right number in there. So now the controller knows how much flow it has available or how big of a pipe it has. Next step, right, we're just going to turn it on. So we're going to come into my main line, and all I'm going to do is click Manage by Flow. Manage by Flow is ready to run as soon as I save. Mm-hmm. One more step though. We're going to go back into that zone concurrency, and we're going to change this. We're going to crank this way up. I'm going to crank it up to 15 zones for the program. And that 15 zones is based off of the controller capacity. So each controller, or the transformer specifically, if we're running 2-wire, each controller can run up to 15 zones concurrently spread out across the system. So 15 zones, 15 2 GPM zones. Well, 15 times 2 is 30. So it could run that. We could run 10 5 GPM zones or 150 GPM zone, whatever it is, up to that 50 GPM. So in this case, it wouldn't exceed more than 15 zones, and it would never exceed 50 gallons a minute.
Right. The important piece being, because you set it to 50 and you said manage by flow, and you check that box, it will use 50 gallons a minute, but no more than 15 zones. And like you just said, it's not likely a combination of 15 zones is probably much greater than 50, but it will only do 50 because that's the most restrictive value. And you may mention this, but I'll just say it anyway. If you set the concurrency to 1, it'll still only run 1, even though it could run up 50 gallons a minute, because if you would have restricted it to just 1 zone.
Right. You essentially handcuffed it by not increasing the concurrency. So we want to give it as much possibilities as possible, as many options as possible.
Yep. So if you do want to manage really by flow, you should open up that concurrency, like you just said, to let the controller have as much variability with those puzzle pieces to fit them all together, the puzzle pieces being zones.
Right. Spot on. Let's talk about moving beyond this start time, right? So manage by flow is about managing, or it's about maximizing that design capacity. So we're going to take that 50 gallons a minute and just do everything we can with it. Let's let 50 GPM run through that pipe the entire time if it can. Let's keep it as close to 50 gallons a minute, and that's as efficient as possible. But what happens if you still run out of water window time, right? So ultimately what's going to happen is you're going to have zones that don't get water. Maybe the first 35 zones get water, but zones 36 through 40, they never get watered because they keep getting cut off every time. So there's a really interesting concept that Chris, I'd like you to bring up. I'm going to stop sharing the screen because I don't need any more of this one.
And I'm going to cancel the spotlight here, which was a bit of an experiment, but since you were doing most of the talking, we'll jump back. Now we can each be on screen.
Cool.
Excellent. So if you have water windows set up and you have programs set to water within those water windows, and your program runtimes actually exceed what your runtime or your water window is, you will get a message at the controller that indicates that you had a program overrun. And what that means is that there wasn't enough water window available for that program to run all of these zones that were assigned to that program to operate given that program start time. So we give the user information back that says, hey, this was programmed. The water window wasn't open wide enough for us to finish watering all the zones in that program. So that allows the user then to make programming decisions. They can decide if they want to shorten their runtimes on their zones in order to fit within that water window, which could instigate or introduce a deficit water scenario, because you may not be able to provide enough runtime for those zones to put down as much water that may be required by the plant material. Or you can open your water window further, right? So we give you a message so that you can make a management decision. Another way that you could think about it, and this is something that I talk about on a pretty regular basis, and I practice on my own property, and that is thinking outside of the start time. So traditionally, a start time is a start condition in any control system. So Tuesday at 8 o'clock is my start time, and I've got 12 hours to water until 8 in the morning the next day. When you think outside the start time, you may not need a start time to be your start condition. You could use a smarter instrument such as a soil moisture sensor to help you decide when to start watering and when to provide irrigation to your plant material. So if you have your moisture sensors, your start condition, and it is programmed and configured to start a program when an allowed depletion is met, then given an open water window, whatever that sensor or whenever your landscape dries out to that start condition, it will start to irrigate. And that could be at 8 o'clock on Tuesday, or it could be at 3 in the morning on Thursday. Just whenever that water window is open, it is going to start the program and allow irrigation to happen to provide replenishment to your landscape based on the evaporation from the soil and the transpiration from the plant material itself.
So Chris, I want to clarify this for myself. So the sensor is dried down and it's ready to water, but the water window isn't open yet because you've decided it's not okay to water. So as soon as that water window opens, then it's ready. It's going to start watering, but not until the water window opens.
Correct. Yep.
Okay.
Yep. So, and you would have a visual indicator of essentially a pause condition occurring when that water window, when the system wants to run, but it can't. You get that pink pause condition indicator that something would like to run, but the controller is paused, which in this case would be due to water window restriction.
Correct. Yep.
So then
if your depletion comes up at 5 p.m., your window doesn't open until 8 p.m. At 8 p.m., you'll start irrigating that program, and it will run that program until that water window closes. Or until the program finishes. So if the program finishes at 10 p.m., great. If it runs through the night and your water window closes at 8 a.m. and the program's not done, as soon as the water window reopens at 8 p.m. later that day, it will resume where it left off. And then if that zone that has the sensor buried in it reaches its allowed depletion again during that process, then as soon as the system stops operating and that program finishes, it'll start over and it'll run through again. So it's just a continual revolution of that program as long as that water window is open and that start condition is met, dictated by the moisture sensor. Okay, different way to think about irrigating, but it is watering essentially on demand when the landscape requires it, based on that input from the soil moisture sensor.
Yeah, essentially a fully automatic system, fully automated at that point.
So you've got a continuous loop that's always running, if you will. It's just pausing when you as a water manager decided it's not okay to water because you have activities going on your site, or pause because it's not dry. It's the moisture level's high enough that it doesn't need it. So to Andy's point, that's fully automatic.
So if you've got rain events that occur during that water period, then it's going to respond to it as well, and either allow irrigation when that window is open or not, based on effective rainfall events.
I mean, what's so hard about this is it's a little bit of a mind blown type of thing, right? Because we're so used to. I've done 35 years of start times. It's like, well, you gotta have a start time, right? What? Actually, not.
You don't need to have a start time. You need to have a start condition. And there's a difference.
Yep.
Right?
Inside of a building, the heating and cooling, the condition will be temperature. That's the start condition.
Oh, the thermostat concept.
Yep. And the landscape, of course, it should be based on water and or moisture, because that's what we're doing.
Correct.
Awesome. That's cool.
So different manufacturers manage these things in different ways. So we've got a question that asks, there's controllers that reduce the runtime for all stations in the event of an insufficient water window. In order for all stations to get some water, does the baseline controller do that? Not in the way that other manufacturers do that. We don't actually limit the runtime. So depending on the watering strategy that's employed, if it's a lower threshold strategy, then the zones will run for the time that is programmed into the controller. If it is, let's see, I'm trying to determine how we would vary in that regard. So the answer would be no, we don't adjust the runtime based on the water window, but we do handle it in different ways.
But having that,
ideally, we want to keep as much hydraulics running through that system as physically possible. So, maybe what we should do is mention some of the things that make what Dan talked about with maximizing that 50 gallons a minute kind of real. So, if you do have a flow sensor, which we'd encourage you to use, and you were trying to run that 50 gallons a minute, and it's running at 47, let's say, and zone 6 has a high flow alert and it shuts down. And if that was a 15 gallon a minute zone and the controller determines that it was that zone, it will then go look for another zone to fill in the remaining allotment on that main line to try to keep 50 gallons a minute going in real time. So there are competitive products out there that don't actually do that fill in real time. They may be pre-programmed with the zone concurrency ahead of time in a fixed state, so that number 6 and number 9 and number 22 are planned to run together, and it initiates. But if one of those zones has a failure, a lot of other control systems won't go pick up another zone to fill in the gap to keep 50 gallons a minute running through that pipe.
Now, another way it could be managed in using a baseline system is if you are in a restrictive scenario, and there are zones that you want to make sure get water, you can prioritize programs, so that if a program is running and a program comes up of a higher priority, it will pause the lower priority program, run the higher priority program, and then if there is a window available after that higher priority program is run, then it will resume the lower priority program when it is finished. So there's different ways to manage and handle these restrictions, so that you can ensure that those zones that are high critical or high profile zones get irrigated when they need to.
Yeah. One example of that would be a shared main line that's being used for athletic fields and landscape, where of course the athletic fields are high priority. So if a coach runs the program before practice that's on that's on the field, and the landscape happens to be running at that time, the landscape can pause, the athletic field will run, and then the landscape will resume after that higher priority program is finished.
What's interesting is when I was a water manager, that the way you would address priorities in a non-baseline universe was you have the higher priorities start first and the lower priorities start second. So make sure it always gets done. But what you just laid out, Andy, that was pretty much on-demand watering for that field. And how do you can't put that in there. So this allows that on-demand and still prioritizing one water source or one program over another. Nice. Okay.
All right. Very good. We've got another question regarding dry run. Is there a report that can show runtime? Dry run is old school thinking, ? Again, going back to us using real-time data to operate and optimize the performance of the system, dry run charts is math-based type operation, where it takes the flows, multiplies it by the run times, the number of zones that need to run, and gives you a run chart to operate from. But like Andy said, a lot of those systems aren't able to react to variances that may occur based on high flow variances or concurrent flow variances based on the size of the system. So it makes it very difficult to provide a dry run chart that is going to be accurate when you're using real-time data during operation.
Yeah, having that real-time data, to me, that's incredibly valuable.
Yep.
And the real-time adjustments as needed.
And if something does go sideways, let's say, a message will be reported that there was a program overrun. So if it happens, we will definitely alert the user that there was an overrun, and perhaps there was something that caused the system to pause. Maybe the user went into the controller for an hour and changed some programming. Everything was paused, and then it resumed, and it overran. But every time it does, we'll definitely let the user know that there was a program overrun.
Mm-hmm. Nice.
All right, gentlemen.
Good stuff. Again, thank you, Dan.
30 minutes has flown by. What do we have on tap for next week?
Next week, we're going to be joined by Lisa Rienstra, one of our baseline RSMs, and we're going to take a look at the base station 3200 as a site controller, essentially running things other than water. Kind of see.
Awesome.
She has a couple really interesting case studies to look at.
Very
excellent.
Good. We look forward to that. All right.
Okay. Thanks everyone for joining
us. Everybody
we'll see
go out
you all
and
next
have a great week.
Cheers. Bye.
All right. Take care, all.